Hi, welcome to another lesson with Dr. Hill. Today what we're going to do is we're going to draw the structures of all the alkenes up to 8 carbons in the structure. And we're just going to do that on the board. So let's have a quick look and see if there are going to be any problems with understanding this. Probably not. The only issue is that isomerism comes in and we have to carefully name the structures as we go. So let's, and we're not going to do all the isomers of some of the larger carbon alkenes, so because it's going to be too tricky, but you'll be able to see how those isomers come off. And you can attempt to try and draw them all yourself. There'll be quite a few for an octene. Okay, but let's just have a look at the board and we'll start there. So we obviously we don't have an alkene with a single carbon in it because you can't get a double bond between a single carbon and a hydrogen. That doesn't happen. So our alkenes are going to start with ethene, and ethene has only one structure. And if we draw it over here on the left, we'll just take, it's a carbon with a double bond, 2 carbons double bond, and that's nice and simple. Okay. Now, when you're drawing these structures, make sure you count the bonds. The bonds are represented by lines. Each atom is connected to the rest of the structure by lines. All right, those are the bonds. Now, carbon can have up to 4 bonds. So this carbon here, 1, 2, 3, 4. There you go. And this carbon here, 1, 2, 3, 4. If you ever have a carbon with 5 lines connected to it, or only 3 lines connected to it, you need to check your structure. That is, this one here, though, is ethene. Remember, the name is eth for 2 carbons and ene for the alkene, the homologous series. Okay, so let's look at the next one. Remember, we've got meth, eth, prop. So we'll have a look at propene. Again, this is 3 carbons, 1, 2, 3. We're going to have a double bond in the structure. And again, 1, 2, 3, 4. Here, 1, 2, we have to have a bond there, 3, so there's only going to be 1 hydrogen coming off that one. And then on this, we're going to have our 3 hydrogens. So that puts all our hydrogens in. And there's the structure for eth prop ene. Now, technically, you can get 2 double bonds in an alkene, but we're not going to worry about that at National 5 level. Okay, so our next one is going to be butene. Now, butene has 2 possible structures. As you can see, we're going to put 4 carbons in. Now, I can either have a double bond here, which would be the same if I flip it, or I can have a double bond here, which would be the same that as I flip it. So we'll draw both of these. We'll put our double bond there first, and we'll see how the name is affected. So I've got 2 bonds in this carbon. It only leaves 2 left for hydrogens, 1 and 2. Then I've got 3 bonds on this carbon, so there's only 1 bond left for a hydrogen. Okay, and then I've got 2 bonds in this carbon, so I can get 2 hydrogens onto it. And I've got 1 bond on this carbon, so we have to get the other 3 bonds connected to hydrogens. All right, so this is going to be our butene. Now, in the name, what we do is we separate the prefix, the but, from the suffix, the ene, by a number to indicate where the double bond is. The double bond is always the lowest possible carbon number possible, and you count from one end of the molecule. So I can't count from this end, 1, 2, 3. It could be theoretically but3ene, and that would make sense to people in terms of they'd be able to draw the structure, but it's not how it's done. And we have to count from the lowest possible number. We put the lowest possible number in here first, and that's going to be 1. So it's but1ene. Okay, so that's but1ene. Let's draw but2ene, because as I said, we can have the structure in the middle. So I'll just do this. And again, let's count. This carbon only has 1 bond at the moment, so I can put 3 more bonds in. 1, 2, 3. This carbon has 3 bonds, so it can only have 1 extra bond. This carbon has 3 bonds, so it can only have 1 extra bond. And this carbon has 3 more bonds available. So let's put our hydrogen in. Hydrogen, 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 hydrogen. Now, as I mentioned in the previous video, in our previous lesson, this would be the cis version of this molecule. There's a slight isomerism here where we have to indicate that the structure is slightly different. If both hydrogens occur on the same side of the double bond, that's a cis structure. If they occur on opposite sides of the double bond, that's a trans structure, and it doesn't rotate. But for the moment, we're just going to not worry about that, and we're going to call it bute. Now, it's on carbon number 2. The first carbon we come to that's got a double bond attached to it is carbon 2, so it's bute-2-ene. Okay, now you can see that as we increase carbon numbers in these, we're going to have to pay careful attention to the number of isomers that there are. So let's have a look at our pentenes. So let's see, 5 carbons. 1, 2, 3, 4, 5. Now, where can I put a double bond here? I can put a double bond here, and that would be the same if I flipped it over as having a double bond here. So that's 1 possible isomer. And then I can have a double bond here, and that would be the same if I flipped it over. So let's start off with the pent-1-ene, which is this one. Pent-1-ene. So that's pent. I'm not going to draw the hydrogens. But if you do draw the hydrogens, make sure you count the carbon bonds. The number of bonds total. There are 2 on this carbon, right? So it can have 2 hydrogens. That makes 4 bonds altogether on the carbon. And then this one here has 3 bonds already, so it can only have 1 hydrogen. The rest will be 2 hydrogen, and 3 hydrogen. Okay? But I'm not going to draw the rest of them in. We're just going to save a little bit of time. All right, so let's look at the next one. Pent-2-ene, which will be C blank C. Okay, now pent-2-ene, you could say, well, you could have one at 3, but then if I flip that molecule over, it's going to be the same as pent-2-ene. So this is pent-2-ene, and those are the isomers of pentene. And then, of course, it gets more complicated with hexene. So let's see, we'll just draw a few hexenes. So C, that's 1, 2, 3, 4, 5, 6. Connect that all up with single bonds. So if I flip that, it's going to be the same as this. So that's hex 1-ene, etc. You're going to get a hex 2-ene. And then if we flip it, and there's going to be a hex 3-ene as well. So you're going to get 3 possible isomers for hex-ene. And you must put where the double bond is. Heptene, we'll just draw one example. So we'll do hept 1, 2, 3, 4, 5, 6, 7. Double bond 1, 2, 3, 4, 5. Hept 1-ene. And then finally, I'll do a big octene down here. 1, 2, 3, 4, 5, 6, 7, 8. Let's pop in a double bond and put the rest of them in. Okay. And the double bond for octene here is, well, let's count the carbons. 1, 2, 3, 4, 5. Is it going to be oct-5-ene? Or is it going to be oct-1,2,3-ene? Of course, it's going to be, we have to choose the lowest number. So even though it's drawn this way, the double bond, we count to the double bond with the lowest number possible. So 1, 2, 3. So that's oct-1,2,3,3-ene. All right. There you go. That's our introduction to the alkenes and some of their structures. Obviously, there's a few isomers that we haven't drawn in that particular group, and I've been leaving out the hydrogens. In the next lesson, I'm going to show you how to draw structures using line angles, because it's an awful lot simpler. It's not required for National 5 chemistry in Scotland, but it's very useful if you're going to do some revision on the internet, because it's a very easy way to draw hydrocarbons and organic molecules as a whole, But next lesson we're going to practice drawing some from their names. Okay, so I think we've done that in less than 10 minutes. I'll say cheery bye now, and we'll call it a day. Thank you.